Alright, we're going to read through what are optionals in Swift. So you can use if and let together to work with values that might be missing. These values are represented as optionals. An optional value either contains a value or contains nil to indicate that the value is missing. Write a question mark after the type of a value to mark the value as optional. So an optional in a Swift is a type that can hold either a value or no value. Options are written appending a question mark to any type. So var name : string question mark equals birdie. Optionals along with generics are one of the most difficult Swift concepts to understand because of how they're written and used. It's easy to get them wrong. And so compare the optional above to creating a normal string. So var name : string equals birdie without the question mark. So from the syntax, it looks like an optional string is very similar to an ordinary string. It's not. An optional string is not a string with some optional setting turned on. It's not a special variety of a string. A string and an optional string are completely different types. Here's the most important thing to know. An optional is a kind of container. An optional string is a container which might contain a string. An optional int is a container which might contain an int. Think of optional as a kind of parcel. Before you open it or unwrap in the language of optionals, you won't know if it contains something or nothing. You can see how optionals are implemented in the Swift standard library by typing optional into any Swift file and command clicking on it. Here's the important part of the definition. Enum optional is wrapped with case none or case some of wrapped. So optional is just an enum, which can be one of two cases, .none or .sum. If it's .sum, there's an associated value, which in the example above would be the string hello, and optional uses generics to give a type to the associated value. The type of an optional string is not a string, it's optional, or more precisely, optional of a string. Everything Swift does with optionals is magic to make reading and writing code more fluent. Unfortunately, this obscures the way it actually works, and so I'll go through some of the tricks later. Note, I'll be talking about optional variables a lot, but it's fine to create optional constants too. I mark all variables with their type to make it easier to understand types being created, but you don't have to in your code. So how to create optionals? To create an optionals, append a question mark after the type you wish to wrap. Any type can be optional, even your own custom types. You can't have a space between the type and the question mark. So var name : string question mark equals Bob. So this creates an optional string. Var Peter : person question mark equals person. So this creates a new optional person. Now, a class with a string and an optional string property, class car, var model name : string. So the string must exist. Var internal name : string question mark. So may or may not exist, it's an optional. So using optionals, you can compare an optional to nil to see if it has a value. So var name : string question mark equals Bob. So the string has a value Bob. Name equals nil, so let's set it to nil. Now if name is not equal to nil, print there is a name. If name equals nil, print name has no value. This is a little confusing. It implies that an optional is either one thing or another. It's either nil or it's Bob. This is not true. The optional doesn't transform into something else. Comparing it to nil is a trick to make easier to read code. If an optional equals nil, this just means that the enum is currently set to .none. Only optionals can be nil. If you try to set a non-optional variable to nil, you'll get an error. So var red : string equals red. Red equals nil. Error. Nil cannot be assigned to type string. Another way of looking at optionals is as a complement to normal Swift variables. They are a counterpart to a variable which is guaranteed to have a value. Swift is a careful language that hates ambiguity, and most variables are defined as non-optionals, but sometimes this is impossible. For example, imagine a view controller which loads an image either from a cache or from the network. It may or may not have the image at the time the view controller is created. There's no way to guarantee the value for the image variable. In this case, you would have to make it optional. It starts as nil, and when the image is retrieved, the optional gets a value. Using an optional reveals the programmer's intent. Compared to Objective-C, where any object could be nil, Swift needs you to be clear about when a value can be missing and when it's guaranteed to exist. To use an optional, you unwrap it. An optional string cannot be used in place of an actual string. To use the wrapped value inside an optional, you have to unwrap it. The simplest way to unwrap an optional is to add a exclamation mark after the optional name. This is called force unwrapping. It returns the value inside the optional as the original type, but if the optional is nil, it causes a runtime crash. Before unwrapping, you should be sure there is a value. So var name :string ? equals Bob. Let unwrap name :string equals name ! Print unwrapped name : escape the parentheses, unwrapped name, close parentheses, quote. So let nil name : string equals name ! would cause a runtime crash because the nil is unexpected when we unwrap it. Checking and using an optional. Because you should always check for nil before unwrapping and using an optional, this is a common pattern. Var meal preference : string ? equals vegetarian. If meal preference is not equal to nil, let unwrap meal preference : string equal meal preference ! To unwrap it, and then print meal unwrapped meal preference, or do something else useful. In this pattern, you check that the value is present, and then when you're sure it is, you force unwrap it into a temporary constant to use. Because this is such a common thing to do, Swift offers a shortcut using if-let. This is called optional binding. Var meal preference : string ? equals vegetarian. If let unwrap meal preference : string equals meal preference, then print the meal unwrapped meal preference. This creates a temporary constant or variable if you replace let with var, whose scope is only within the if braces. Because having to use a name like unwrapped meal preference or real meal preference is a burden, Swift allows you to reuse the original variable name, creating a temporary one within the bracket scope. So, var meal preference : string ? equals vegetarian. If let meal preference : string equals meal preference, then print the meal preference. Here's some code to demonstrate that a different variable is used. So var meal preference : string is vegetarian. If var meal preference string equals meal preference, print meal preference equals beef, there's no effect on the original. This is the original meal preference, print meal preference, and it prints the optional vegetarian. So optional binding works by checking to see if the optional equals nil. If it doesn't, it unwraps the optional into the provided constant and executes the block. In Xcode 8.3 and later, Swift 3.1, trying to print an optional like this will cause a useless warning. Use the optional's debug description to silence it. So you can print meal preference.debug description. So we have learned about optional binding, where we basically will unwrap it after checking to see that it's nil, and put in the same variable if you like to. So what are the optionals for? Optionals have two use cases, things that can fail. I was expecting something, but I got nothing. Or things that are nothing now, but might be something later, and vice versa. Some concrete examples. A property which can be there or not there, like middle name or spouse or in a person class. A method which can return a value or nothing, like searching for a match. A method which can return either a result or get error or nothing, like trying to read a file's contents, or the file doesn't exist. Delegate properties, which don't always have to be set and are generally set after initialization. For weak properties in classes, the things that they point to be can be set to nil at any time. A large resource that might have to be released to reclaim memory. When you need a way to know when a value has been set, data not yet loaded or greater than the data, instead of using a separate data loaded boolean. Optionals don't exist in Objective-C, but there's an equivalent concept, returning nil. Methods that can return an object can return nil instead. This is taken to mean the absence of the valid object and is often used to say that something went wrong. It only works with Objective-C objects, not with primitives or basic C types like enums and structs. Objective-C often had specialized types to represent the absence of these values, like ns not found, which is really ns integer max, kcl location coordinate 2D invalid to represent an invalid coordinate, -1, or some negative value are also used. The coder has to know about these special values, so they must be documented and learned for each case. If the method can't take nil as a parameter, this has to be documented. In Objective-C, nil was a pointer, just as all objects were defined as pointers, but nil pointed to a specific 0 address. In Swift, nil is a literal, which means the absence of a certain type. Comparing to nil, you used to be able to use any optional as a boolean. Let leather trim, car extras, ? Equal nil. If leather trim, then price equals price plus 1000. In more recent versions of Swift, you have to use leather trim not equal nil. Why is this? The problem is that a boolean can be wrapped in an optional. If you have a boolean like this, var ambiguous, boolean, ? Equals false, it has two kinds of false, one where there's no value and one where there is a value, but the value is false. Swift hates ambiguity, so now you must always check an optional against nil. So you might wonder, what is the point of an optional boolean? As with other optionals, the .none state could indicate that the value is as yet unknown. There might be something on the other end of a network which takes some time to pull, and optional booleans are also called three-value booleans. So, Swift tricks. Swift uses some tricks to allow optionals to work. Consider these three lines of ordinary-looking optional code. Var religious affiliation is a string Rastafarian. Religious affiliation equals nil. If religious affiliation is not nil, then do something. None of these lines should compile. The first line sets an optional string using a string literal, two different types. Even if this was a string, the types are different. The second line sets an optional string to nil, two different types. The third line compares an optional string to nil, two different types. I'll go through some of the implementation details of optionals that allow these lines to work, creating an optional. Using ? To create an optional is syntactic sugar, enabled by the Swift compiler. If you want to do it the long way, you can create an optional like this, var name, optional string equals optional Bob. This calls optional's first initializer public init underscore sum colon wrapped, which infers the optional's associated type from the user type from the type used within the parentheses. The even longer way of creating and setting an optional is to say var serial colon string question mark optional dot none serial number equals option dot sum 1 2 3 4 print serial number dot debug description. Setting an optional to nil, you can create an optional with no initial value or create one with initial value of nil. Both have the same outcome. Var name colon string question mark var name colon string question mark equals nil. Allowing optionals to equal nil is enabled by the protocol expressible by nil literal, previously named nil literal convertible. The optional is created with optional's second initializer public init nil literal colon parentheses close parentheses. The docs say that you shouldn't use expressible by nil literal for anything except optionals, since that would change the meaning of nil in your code, but it's possible to do it. Class Clint colon expressible by nil literal var name string question mark required init nil literal colon name equal the man with no name. Let Clint equals nil would normally give an error, but print Clint.name. The same protocol allows you to set an already created optional to nil. Although it's not recommended, you can use the nil literal initializer directly, as so. Var name colon optional string optional nil literal colon parentheses. Comparing an optional to nil. Optionals define two special equal and not equal operators, which you can see in the optional definition. The first equal allows you to check if an optional is equal to nil. The two different optionals which are set to .none will always be equal if the associated types are the same. When you compare to nil behind the scenes, Swift creates an optional of the same associated type set to .none, then uses that for the comparison. How Swift actually compares to nil. Var tuxedo required colon string question mark equals nil. Let temp colon optional string equal optional dot none. If tuxedo required equal temp, equivalent to if tuxedo required equal nil, print tuxedo required is nil. The second equal operator allows you to compare the two optionals. Both have to be the same type, and that type needs to conform to equatable, the protocol which allows comparing things with the regular equal operator. Swift presumably unwraps the two values and compares them directly. It also handles the case where one or both of the optionals are .none. Note the distinction between comparing to .nil literal. Furthermore, it allows you to compare any equatable type to optional wrapping that type. Let number to find int equal 23. Let number from string colon int question mark int 23. If number to find number from string, print it's a match. Print it's a match. Behind the scenes, Swift wraps the non-optional as an optional before the comparison. 2. If 23 equals number from string. I said there are two equal operators, but there's actually a third which allows you to put nil on the left side of the comparison. If nil equal name naming optionals, there is no Swift convention for naming optional types. Differently from non-optional types, people avoid adding something to the name to show that it's an optional, like optional middle name or possible number as a string, and let the declaration show that it's an optional type. This gets difficult when you want to name something to hold in value from an optional. The middle name implies that it's a string type, so when you extract the string value from it, you can often end up with names like actual middle name or unwrapped middle name or real middle name. Use optional binding and reuse the variable name to get around this. The official definition from the basics in the Swift programming language. Swift also introduces optional types which handle the absence of a value. Optionals say either there is a value and it equals X, or there isn't a value at all. Optionals are similar to using nil with pointers in Objective-C, but they work for any type, not just classes. Optionals are safer and more expressive than nil pointers in Objective-C and are at the heart of many of the Swift's most powerful features. Optionals are an example of the fact that Swift is a type-safe language. Swift helps you to be clear about the types of values your code works with. If part of your code expects a string, type safety prevents you from passing an int by mistake. This enables you to catch and fix errors as early as possible in the development process. To finish it, here's a poem from 1899 about optionals. Yesterday upon the stair I met a man who wasn't there. He wasn't there again today. I wish he would go away. Antigonish. Alright, that's it for optionals in Swift.